we have just discussed the roles of lipids inside the body. And these are the three roles of lipids inside the body. And the first role we discussed was storage in the triglyceride molecule. And how that happens is with the understanding of the fatty acid. So this is the fatty acid right here. And before we proceed, there are two kinds of fatty acids. The first kind of fatty acid we have is a saturated fatty acid, and the other kind of fatty acid we have is an unsaturated fatty acid. Now, you might be asking yourself, what is the difference between these two fatty acid chains? And before we answer that question, we have to understand what saturated means in the first place. If something is said to be saturated, like a sponge, if a sponge is saturated with water, that just means that it's filled up, it's soaked in water. And just like that, we can apply the same theory to the fatty acid structure. And that just means that there are no hydrogens the hydrogen is equally distributed throughout the fatty acid chain. And this is what a saturated fatty acid looks like. And this is how you're going to see it in your textbook. And if you don't understand the chemical structure of this fatty acid, don't be worried. We're just going to understand it in a second. So this is the same fatty acid copy pasted right over here. And the hydrogens, just notice that every nod that you see on this fatty acid is going to be a carbon. And if we look at this fatty acid structure, or these everything inside over here on a more molecular base, that looks like this. So do a quick comparison. We have a nod, a nod, a nod, a nod, and I said a nod represents a carbon. Just like that, we have a carbon, a carbon, a carbon, a carbon. And with each of these carbons, we have hydrogens attached. And these hydrogens are hard to draw out when you want to make complicated, complex structures. So we just assume that they're there when they're not written down. So this is why this is how it looks like. So that's a carbon. We know there's a carbon over here. We know there's a carbon here. And then we know that carbons can make 4 bonds. 2 of those bonds are going to the hydrogen, and the remaining 2 will go to the other carbons. Then this is how the fatty acid structure is basically is composed. So when something is saturated, that just means that the hydrogens are equally distributed, and that's only possible if we have single bonds. And you might be thrown off by the carboxylic acid here. And the carboxylic acid is not determining if something is saturated or not. What determines the saturation is the main body of the fatty acid, which is right over here. And if we see a double bond between any of the carbons in the chain, we will notice that it's not saturated, and therefore it's unsaturated. And unsaturated means that there isn't an equal distribution of the hydrogens. And then, so basically, if you want to memorize this, a saturated fatty acid will have no double bonds. It's filled up with hydrogen. Of course, excluding the carboxylic acid that's not part, which is part of it, but it's not part of the main body of the fatty acid. And then we have unsaturated fatty acids. There is at least one double bond between the main body structure of the fatty acid. And if we have double bond, we kind of have this structure that's formed. It kind of bends the entire molecule. If we have, let's say that this is a representation of a saturated fatty acid, and if we have a double bond, what it's going to do is going to kind of make it look like that. This double bond is going to give it a little bit bent. That's called a kinked. I don't know how to say this, a kinked, I guess, but it's just a bent that's given to the entire structure. And if we look inside the phospholipid bilayer, and if we have a unsaturated fatty acid, it's going to give more fluid space inside the phospholipid bilayer. And there is something else that is good to bring to attention. In unsaturated fatty acids, we have 2 kinds of unsaturated fatty acids. We have a trans and we have a cis. if you remember, your biology, you might know that there's some good fats and bad fats. We don't know the difference right now, but this will help you understand what good fats are and bad fats are. If something's a trans unsaturated fat, then it's bad for you. If something is a cis, if something is a cis unsaturated fat, it is good for you. But what makes these two unsaturated fats different from each other? And that can be answered by this little drawing right here. Remember how we said that there has to be at least one double bond between the fatty acids inside the main structure, and if that happens, the hydrogens either have to go facing up proportionally to one another, such as right over here, or it could be trans, which means it's on the opposite ends of one another. And what this really does, it gives very different characteristics, which determine which does a lot of things in your body, and it's really complicated, and it's not supposed to be explained in this video. But these are bad for you. Trans unsaturated fats are bad for you. Cis saturated fat, I said saturated. Unsaturated fats or cis unsaturated fats are good for you. So, okay, last thing to mention real fast is a missile. We have just discussed what fatty acids are, and we must recognize that this right here is is polarized, and therefore this is soluble in water. And the whole reason we have fatty acids being partially soluble in water is because of the carboxylic acid. If we throw these fatty acids inside a solvent, which is water, what's going to happen is we're going to have these hydrophilic tails on the outside, and the hydrophilic carboxylic acid will be facing on the outside of this structure. So the missile is a structure that's a round globular structure, which resembles a ball, I guess. And on the outside, it's hydrophilic, which means it's water loving. This is done the other way around. This is hydrophilic. Yeah, this is done. Let me just fix this real fast. Let's get this. This is supposed to be representing the blue one, and this right here is supposed to be representing the red one, the red stuff. So the hydrophobic stuff in the middle is not water loving, and that's the main carbon tail, and the hydrophilic stuff is on the outside, which is water loving, and it allows the whole structure to be compatible inside water. So now we basically understand what fatty acids are and what unsaturated and saturated fatty acids